so that you can watch it again later. As soon as we're done, you can go to my YouTube channel and you can re-watch it if you need to. And of course, you can review on this Jamboard any of the stuff that we've been doing as well. Okay. So this one says, what does it say? Find, does it say find the inverse of the following function?
Yeah.
Okay. So I'm going to write it over here so it's easier to see. G of x equals 3x minus 5 over 4. All right, so if I want the inverse of this, what I do is I change the x and the y. I just interchange them.
Mm-hmm.
So I write, instead of g of x, I write x. And instead of 3x, I write 3y minus 5 over 4. Okay, that's the first step. So you interchange the two variables, x and y. And then all I have to do now is just solve for the new variable, solve for the new y. Okay, so to solve for y, what's the first step I would do to solve for y?
To solve for y, when you... Oh, I'm not sure.
So I need to get rid of all this stuff, right? What do I get rid of first? The 3, the minus 5, or the 4?
The 4.
Right, and how do I get rid of the 4?
Multiply by 4.
Good, so 4x equals 3y minus 5. That's the first step. Now what?
Then you add 5 to the other side.
Good. 4x plus 5 equals 3y. Now what?
Don't you divide by 3?
Perfect. 4x plus 5 divided by 3. There is my inverse.
Mm-hmm.
And then you write it as this. You write g inverse of x equals 4x plus 5 over 3. If in fact it is a function, which this one is. Okay.
Mm-hmm.
Do you know how you can tell if it's a function or not?
No.
So you can tell if it passes the vertical line test, and it, so you can kind of tell that this. You could also rewrite this as 4/3 x plus 5/3,
Mm-hmm.
right? You understand? Like I could distribute this 3 into here and here, and then you can see that that's just a line. That's just a linear equation. And lines are functions as long as they're not vertical lines, because they pass the vertical line test. Now, if you wanted to graph, it didn't ask you to graph, but let's graph it anyway. If you wanted to graph these two functions, you'll notice when you graph them. Actually, let me just rewrite this and let me use your graphing calculator. So this would be this original one up here on the right is 3/4 x minus 5/4, right?
Yeah.
So if I were to graph these two functions on a graphing calculator and put them next to each other, have you talked about that yet? About what happens when you do that?
No.
Your teacher hasn't talked about graphing yet, or you haven't done that yet?
I mean, we've done some graphing, but it was like maybe we have.
Yeah, I'm guessing that you probably have. Do you remember how you can tell if two functions are inverses of each other by looking at their graph? Have you learned about that yet? Have you seen that yet?
Probably. I have to be like shown something.
Yeah. It is. So if the equations, I'm opening up the Jamboard right here so I can see it. So if I were to take my graph, whoops, not that, my graphing calculator, and if I were to plug both of those in, so y equals, so what was that first equation? 3x minus 5, I'm going to use parentheses, 3x minus 5 divided by 4. And the other equation that I got was 4x plus 5 divided by 3. 4x plus 5 divided by 3. If I graph both of those, you'll notice what happens when I graph them. I'm zooming out. Those two equations are symmetric over the line. They're flipped over the line y equals x.
Mm-hmm.
So if I also put y equals x into it, just write y equals x, the line y equals x.
Yeah.
And I graph that as well. You see that middle line right there?
Yeah.
Those two other lines are symmetric, or are reflections over the line y equals x. And the way you can tell that is if you go to the point where they intersect, they're all three of those lines are going to intersect at the same place.
Mm-hmm.
I can find it. There we go. At -5, -5. If you take this point right here, any of those points, let's find a nice point in here. That one right there.
Mm-hmm.
If you you flip the x and the y, if you make the on the other graph, that would be the point where flipping the x and the y, where the x is 0, the y would be that value. Mm-hmm. Basically, the two points would flip. That's what it means to be symmetric. Kind of hard to tell on this graph. But if I were to take it and put it on a graph like this, the red graph up here, mm-hmm. 3/4 and -5/4. So there's your -5/4, and it goes up 3/3. It would be like this. And if I take this blue one, +5/3, which is up here somewhere, and 4/3, it goes up steeper. They're going to actually intersect at -5, -5. And those 2 points are a reflection over this line right here. I didn't draw that very good. So every point here, if you go straight, what it means to be a reflection, if you go straight down to the line and then straight over, that point would be reflected to right there. Mm-hmm. So if you had the point, for example, let's put a nice point in here. 3, well, that's not going to be a nice point. What's going to be 1? If I plug in 1 for x into this blue equation, the inverse, I'm going to get 3 for y, because 4 plus 5 is 9 divided by 3 is 3. So the point 1, 3, well, that looks about like that. That point is 1, 3. And if you put in 3 into the other one, I'm taking the y value and changing it. I'm basically flipping the x and the y value. Mm-hmm. So in the red graph, on the red graph, the point would be 3, 1. So if on the blue graph, the point 1, 3 was on it, when you flip the x and the y, remember I talked about flipping the x and the y to find inverses? Mm-hmm. You're going to get the point on the red graph. So this point right here is 3, 1. And that happens for every point. Every blue point, if you flip the x and the y coordinates, you get to a point that's on its inverse. So remember that when you're talking about inverses, finding inverses. One thing you can do to find the inverse, like I just showed you up here, is interchange the x and the y and then solve the equation. And that'll give you your inverse equation. That's one way if you're given an equation. But if you're given a graph, and maybe you're going to have one of these questions, if you're given a graph, looks like maybe that's what this is. No, this is not that. If you're given a graph and they're asking you for the inverse, then you can literally just take all the points and interchange the x and the y coordinates, mm-hmm. and those will give you points on the other graph. So I don't know if you have to do that yet, but just keep that in mind. We may be seeing that soon. Ready for the next one?
Yeah.
All right. This question says, use the graph to evaluate the following. So when it says evaluate, that means find the value of. Mm-hmm. So to find the value of these, what I'm going to do, f plus g of 2 is the same as f of 2 plus g of 2. So I have to find f of 2. So let's go to my f graph, which is this left one. Go to 2 on your x-axis, right? Because that's what that's what you're talking about, right? Go to the 2 and find out what that y value is. So when x equals 2, what's y equal?
0.
0, perfect. So this is 0 plus, what's g of 2? Go to your g graph, go where? Go to your 2, right? And then go up or down to the graph, and then go over from there to find out what the y value is. So when the x value is 2, the y value is?
2.
2 as well. So what's f plus g of 2?
2.
It's 2. Same for this next one. We're going to take f. We're going to take f of 1 and divide it by g of 1. So what's f of 1? Look at your graph. What's f of 1?
F of 1 is 2.
It's 2. So that's 2 divided by what's g of 1? Go to your g graph. Go to 1.
3.
It's 3. Good job. So 2/3 is your answer. So for number 11, f of 4 minus g of 4. What's f of 4?
4.
4, good. And what's g of 4?
0.
Perfect. So 4 minus 0 equals what?
4.
Perfect. Now f of g f times g of 0, again, f of 0 times g of 0. So first find f of 0. What's f of 0?
F of 0 is 4.
4. What's g of 0?
4.
It's also 4. So 4 times 4 is?
16.
16. Perfect. Now this is the only one that's new. You've never learned this before. This is function composition.
Yeah.
So what you're really going to do here is you're going to take the second function, g, and plug it into the first function. So you're literally finding g of 3, and you're plugging that into the f function as your x value. Does that make sense?
Yeah.
So what's g of 3?
G of 3 is 1.
G of 3 is 1. So what I'm going to do is I'm going to write f of 1, right? Because that's what g of 3 is. So what's f of 1 now?
2.
Now we go back over to our f graph and we look at it, and there it is. It's 2. Okay? That makes sense how that works?
Yeah. I'll be back in like 1 minute.
Okay.
All right, I'm back.
Okay, so this question is asking us, what's g of 2 of x plus 2? So remember, what we're doing is whatever is inside here, functional notation, what they're basically doing is whatever is inside here in the parentheses is what you plug in for all of the x's in the function. See how the x here? See how there's 2 x's? So you literally plug in x plus 2 for those 2 x's. So what I like to tell people to do is, until they really get the hang of this, is go ahead and just write it out, but instead of writing the x, so rewrite g of x, but instead of writing the x, actually I'm going to erase the x too. Instead of writing x, anytime you see where there would be an x, put a big set of parentheses there and leave some space.
Mm-hmm.
So what we're going to do is we're going to literally plug in everywhere we saw an x, instead of x, we're putting x plus 2. So here goes x plus 2 there. There's x plus 2 there. And that's it. Now I have to simplify this probably. They probably want you to put it in standard form. And this is where a lot of people make mistakes. This right, by the way, if they don't need you to put it in standard form, leave it like this because that's the correct answer.
Mm-hmm.
But if they want it in standard form, you know, like ax squared plus bx plus c, then you have to go ahead and multiply this out. Now remember, this right here is like x plus 2 times x plus 2,
Mm-hmm.
right? Which is x squared plus 2x plus 2x plus 4. You see what I'm doing?
Yeah.
Foiling that out. And then this is, if I put this here, this is just 2x plus 4. And then this, of course, is minus 1. So I have x squared plus 4x. Actually, hold on. Let's here's my x terms. So there's 2x plus 2x plus 2x is 6x. And then 4 plus 4 minus 1 is 8 minus 1, which is 7. So plus 7. So g of x plus 2 equals that in standard form. Okay, got it?
Yep.
Did I go too fast, or does that make sense?
No, I understood that.
Okay, so for this next one, we're going to do that same thing. Negative 2 times f of 3x, 3x is equal to, well, first of all, you put the negative 2 on the outside because we're going to have to multiply that through at the end. And f of x, look up here, f of x, there's actually only one x in there. So I'm going to rewrite my f of x, but I'm going to leave a parentheses every time I see an x. And what's going inside that parentheses now?
Negative 3x minus 2.
Nope, just 3x is going in there.
Oh, wait.
You understand?
Oh, because we're putting 3x into the function.
Yeah, the 3x is what they want to know what f of 3x is, meaning instead of f of x, f of 3x, what's the function value of 3x, not the function value of 1x. So everywhere you see an x in the function, you put in a 3x there instead. Now we simplify it.
Mm-hmm.
So that equals negative 2 times, what's this equal?
Negative 9x.
Good. Minus 2. Now what do I do?
You do. Wouldn't you just multiply those two by 2? Negative 2.
By negative 2. So what am I going to get?
18x plus 4.
Perfect. There you go. That's the answer. Got it?
Yep.
Next up. Oh, here we go. I told you we were going to see this. You have a dinosaur living in your house? Looks like there's a dinosaur shadow in the back. Like a T-Rex. All right, it says graph both on the same coordinate plane, then find the equation of the inverse. All right, so we're going to first of all find the equation of the inverse, or maybe we can graph it. So I'm going to show you the different ways we can do this, okay? So remember what I told you. One way you can do this is you can make a table of values, x and f of x. And so let's just make some values up. Let's go with negative 2, negative 1, 0, 1, and 2.
Mm-hmm.
So when I plug in negative 2 here, what do I get? Actually, let me erase the odd ones. Let's just get 3. We really only need 2 points, but let's just do those. Now, the reason I'm picking 2 and negative 2 is because when I take half of 2, what do I get?
Negative 2 or 1.
I get 1, exactly. So I wanted it to be a whole number. I didn't want to have to deal with decimals,
Uh-huh.
right? So when I plug a -2 in here, that becomes a +1 plus 3 is what?
4.
Good. When I plug 0 in here, that goes away, plus what?
3.
3. When I plug a +2 in here, that becomes a -1. What's -1 plus 3?
2.
2. So there are my 3 points. Okay. Now watch what I'm going to do. I'm going to actually, yeah, I'll just go ahead and do it on the graph. I'm going to graph this in yellow. So -2, 4 is up there. 1, 2, 3. Is that right? 1, 2, 3, 4. Yep, that's right. 0, 3 is right here. And 2, 2 is right there. So that, remember, that's a linear equation, right? So that's just going to be a line. So I'll draw the line in there. Okay. Now, you remember the easy way I told you to find the inverse? If you have a graph, you remember what I told you? What's one of the ways you can find an inverse function? If you have points, what can you do?
Didn't you just like interchange them or whatever?
Yeah, you flip them. So F inverse of X and X, I take all of these X's and I put them, or all the F of X's, and I put them here. And I take all the Y's that were related to, or the X values that were related to them, and those are my new inverse functions, or my inverse values. In other words, I flip the X and the Y for all of them. Got it? That's the easy way to do it if you're doing it on a graph. So now I'm going to take those points and I'm going to use red, and I'm going to plot those points. 4, -2. 1, 2, 3, 4, -2. 4, -2 is right there. 3, 0 is right there. And 2, 2 is right there. Hey, look at that. Those lines, or those points, line up. And it is now what you'll notice about this, I'm going to draw in a black line, the line y equals x. There's the line y equals x, and you see how those two lines are a reflection.
Yep.
The red line is a reflection of the yellow line over the line y equals x, and vice versa. If you reflect it, if you reflect this red line, you would get that yellow line, and vice versa. Now, how do I find the equation? What's the technical way of finding the equation? Remember what I did for the first problem?
Why don't you just plug one of the points in?
Nope. Let's go back to that first page. What did I do? What was the first step? If I was given an equation, what was the first step?
Oh, you had to you had to solve the original one.
And I do what? Before I solve it, what do I do? What did I do here with the x and the y?
Oh, you switch x and y.
Yeah, you flip them. You switch, you interchange the x and the y. So
Yeah.
let's interchange them. X equals -1/2 y plus 3.
Yeah.
And now I have to solve for what?
You subtract 3.
Good. I have to solve for the y, so I subtract 3 first. So x minus 3 equals -1/2 y. And now what?
And you divide by -1/2.
And what's dividing by -1/2 the same as doing?
Multiplying by 2.
Multiplying by
1/2.
-2.
Or -2.
Multiplying by -2. Dividing by -1/2 is the same as multiplying by -2. You understand?
Yeah.
So that goes away, and this becomes -2x plus 6. So the inverse is -2x plus 6. Good?
Yep.
We have another one, or is that it?
That was it.
Okay. Let's do this. Why don't you find some more problems like those, work on them, and come back at 4:30, and I'll give you another 5 or so minutes. Okay.
Okay.
Sound good?
All right. Yeah.
So work on it on your own and then log back in.